Hi, I'm Mike Stone with the National Electrical Manufacturers Association, also known as NEMA, and today we're going to do a demonstration of how to properly torque conductor terminals. And so we're here at the IBEW Training Center in Renton, Washington, and we're in their laboratory where they train apprentices. And what we have today is we have a panel board here with some number 3 copper conductors, and it's fed off of a disconnect here, which you'll see it has locked out and tagged out, but actually you can't see on the film, but this is a training center, and this raceway that goes out of the top of this disconnect is not connected to anything. So we're for sure working on a de-energized circuit, but just make sure in real life, if you're working on a panel board like this, you make absolutely sure that it's de-energized and it's properly locked out and tagged out. Very important. So why use the torque measuring tool in the first place? Why can't I just tighten it up to where it feels good and tight and call it a day? Well, about 90% of electrical failures occur at termination points. They burn up, the conductors burn up, the equipment can fail. And so it's very important that the initial installation is done correctly to the proper torques. And it can take months or years or sometimes even decades for those failures to occur. And they can be caused by having improper torque values at the initial installation. So an under-torqued connection can obviously be a problem because you can have a loose connection, which will create more resistance, which in the long run will create more heat, and your connection will fail. But over-torqued connections can also fail in a similar fashion. You can damage the strands on a conductor, or you can damage the threads on a set screw, and over time those connections are going to develop resistance and again more heat, and they will eventually fail. Torque references first appeared in the 1975 NEC, and it required that manufacturer's instructions be followed for torque values. Then there was a new section added in the 2017 NEC in 110.14d that required that approved methods be followed to comply with the manufacturer's torque values on their equipment. So conductors can be copper, aluminum, copper-clad aluminum. They can be solid stranded or compact stranded. But the same torque values apply to all conductors. It doesn't matter what type of conductor they are. And you can have different types of connectors. You can have set screw connectors. You can have wire terminals like you see on wiring devices or some smaller circuit breakers. You can have wire binding screws on smaller devices. But regardless, the manufacturer's instructions need to be followed. And what types of connections need to be properly torqued? Virtually all. The manufacturers are going to indicate on their equipment what those torque values are. In the case of wiring devices, it can be marked on the box that the switch comes in or wiring device comes in. On a circuit breaker, it could be marked on the circuit breaker itself. On panel boards or equipment like we're looking at today on this panel board, it's marked on the cover. So you would look on the cover there and it'll give you the torque values for those terminations. So today we're using a torque measuring wrench. It's a click type. There's different types of tools you can use for this. You can use other torque wrenches that have digital displays on them. You can use torque measuring screwdrivers. There's also different types of breakaway connectors that will indicate the proper torque when they're torqued down to the proper value. So you want to properly strip and prepare the conductors to make the termination, and we've done that. We've stripped this copper conductor here. It's nice and clean. It's ready to be installed. And one thing you want to make sure of when you do make this connection is, in our example, we have a hex head connector here, set screw. So we have the correct size hex head to go in there, but sometimes you'll have a screw, a slotted screwdriver, or even a Phillips head connector. Then you want to make sure when you do that you use the correct size either slotted screwdriver or Phillips screwdriver, again, a torque measuring screwdriver, to make that connection. Otherwise, you run the risk of not getting the proper torque on there, and you can also damage the connector itself. So again, check the marked torque value on your equipment. You set the torque wrench to the correct value, and then sometimes you may want to use a manual tool to just get it to where the set screw has made contact with the connector just a little bit easier. So you want to strip and prepare the wire to terminate it, and then you want to take your conductor and put it into the connector, whatever that might happen to be, like so. And then in our example, we're going to just tighten it up a little bit by hand with an Allen wrench here, and until it makes contact with the conductor, and that'll make it a little bit easier to use the torque wrench that we're going to use to measure the torque value. And we'll complete the installation with this, like so, and we've set it to the proper value ahead of time until it clicks, and then we know that we have the correct termination. And you'll notice that I put on a pair of safety glasses to do that, so make sure you adhere to all the proper PPE that you need to be wearing. So there are some additional resources that you can refer to. The first one is NFPA 70B, which is the standard for electrical equipment maintenance. And then also the National Electrical Code, which is NFPA 70. And there's an informative Annex I, which includes torque values that can be used. If you have a piece of equipment that's existing and the torque values are either missing from the equipment or they're not there, you can use that informative Annex I for those torque values. And then again, NEC 110.14D for torque values. And then also NEMA has an engineering bulletin number 120, which is the use of torque measuring tools, and you can refer to that as well. Thank you, and I hope you enjoyed this video, and happy torquing.